So today's topic is about Revit global parameters. As you know, Autodesk has introduced 2016 version of Revit R2 recently in the past few weeks, and this is how you can, this is the only way for you to get global parameters, and it's available for subscription customers. So global parameters are specific to a single project file but not assigned to a Revit category. They are simple values derived from equations or values taken from model using other global parameters. The main use for the Revit global parameter is to drive and report values. A global parameter can assign the same value to multiple non-adjacent dimensions. You can also set the position of an element by the size of another element. Let's review together the types of parameters available to us through Revit. So we have the family parameters, project parameters, shared parameters, and now the latest addition is the global parameters. I'd like to take a moment to compare these different types of parameters. So what is a parameter? A parameter is a rule or limit that controls what something is or how something should be. It's also a measurable factor that can help in defining a particular system. So some of the keywords here are rules, limits, what, and how. So for a family parameter, which is available in the family editor, this is specific to the single family file and cannot appear in schedules or tags. And it controls the values of dimensions or material properties of that family. It can also control a parameter in another nested family. A project parameter is specific to a single project file and must be assigned to one or more categories. Appears in schedules but not in tags. Example of that would be programmed room area and the categorization of views within a project. A shared parameter is stored in external file outside of Revit. It's shared by multiple families and project files, appears in schedules and tags, and can be exported to ODBC, which stands for Open Database Connectivity. Specifications in the AEC industry is an example of ODBC exports. So shared parameters must be converted into family or project parameters before the use, and they are stored in a text file outside of Revit and can be exported to a shared parameter file after use, and but they must not be edited externally. So hackers out there, be careful when you edit the file externally. That is not recommended. Unless you know what you're doing, you should not do that. An example to a shared parameter would be the number of elements in a family in a schedule, such as number of shelves in a casework family, room occupancy in a room tag, and custom materials parameters, such as those that relate to COBE and SPI parameters. So I'm pretty sure that most of the listeners and people watching this webinar right now have used some of those parameters before, the family parameters, project parameters, and shared parameters. When it comes to global parameters, these are a little bit different. They are specific to a single project file. These are non-category specific, so you don't have to apply them to a Revit category. They are simple values or values derived from equations, values using other global parameters, and used mainly to drive and report values. Example to that would be to assign the same value to multiple non-adjacent dimensions and set the position of one element by the size of another element. They will appear under the Manage menu in Revit when this is installed as part of the 2016 R2 release of Revit. There's a few more parameters that we need to be aware of as we work with this. One of them is reporting parameters. Reporting parameters is a property of the parameter, but not a parameter by itself. Of course, what's important about reporting parameters is that they can be used for global parameters. And that's a very important part of the use of global parameters. So a reporting parameter it's a value driven by a particular dimension in the family, such as length, radius, angle, arc, length, and are available as reporting parameters. Areas cannot be used as a reporting parameter, and most useful when a family is driven by external references that are updated based on contextual information from place family instances. One last type of parameter is called the part type parameter. That's mainly for when you're working with construction parts. So every parameter in Revit will have to be assigned a type, such as text, integer, number, length, area, volume, angle, slope, currency, URL, material, yes and no, and family type. So to keep this entertaining and not so dry, I wanted you to pay attention to the ones that are indicated with these arrows. So the integer type parameter is a whole number. So you can't have, for example, half a door or half a window. Or if you're doing a count for occupancy, it would have to be an integer because you can't have half a person. Material parameters are also important because they control different types of materials that you create yourself or that you duplicate and modify. Yes and no parameters are true or false parameters, and otherwise called as Boolean parameters. They would appear as yes and no in the schedule. A family type parameter is particularly interesting when it comes to nested families and replaceable components. So again, how do we define global parameters? They are, again, just to remind ourselves, they're non-category specific, variables available to any and most family instances, cannot be applied to materials, report and derive simple values, values derived from equations, and model values derived from other global parameters. Their main use is to derive, associate, and report. They derive values of dimensions or constraints. They associate with an element instance property to derive its value and report the value of dimensions so it can be used in equations of other global parameters. Some of the advanced uses of global parameters is non-adjacent equality. I find this particularly interesting myself, and I'll show you some examples of that in a moment. Dimensional equality to constrain a model is limited to situations where the equal spaces are adjacent, and global parameters lets you assign the same value to non-adjacent dimensions. That's pretty powerful when it comes to code requirements in the building. There's another aspect of this has to do with tooltips, and this is also a recent addition to parameters that can, because of a situation where have you ever been in a situation where you can't even remember what the parameter actually controls? And if you've done that before, then it means that you need that tooltip to remind you what that parameter is. So when you mouse over a parameter, it will tell you what that parameter belongs to. So other advanced uses are setting the position of an element by the size of another, and this happens because mainly global parameters can simplify element positioning without dimensional lock. So for example, when the beams are referenced in the same level as the floor, each beam needs to be offset by the thickness of the slab. Modifications to the floor require that you update each beam type. Global parameters can set the beam's offset value to be driven by that reporting parameter. I'm going to show you some samples, and then I'll switch back to Revit to show you live how this is done inside of Revit. Here's an example where global parameters are used to drive programmed room area and occupancy in the building. I've used here simple labels for global parameters such as A1, A2, C1, C2, and R1, R2. I've leveraged that in areas, define the area of the room, and have that drive the dimension of the room itself. Another example would be to use the global parameters with generic model arrays. I found it particularly interesting when you import a family into Revit and use it for an opening in a wall, such as the one on the right side of the screen right now. That would work much better than having a window that you load yourself. So generic model arrays works better when it comes to global parameters because you can control the instances of those parameters. Another example is this is one of my favorites, is to use that with non-adjacent rooms. Here we have two rooms that are labeled office, and this could be a corridor, for example, and for some reason there could be either design intent or code requirements. You could be looking at having those rooms having the same width. This example is interesting because it has to do with the furniture inside the room. The furniture in this case drives the geometry of the room itself, the size of the room. Here's the example where we have the slab, structural slab in the building, and it has a level offset down to the top of the girder or top of the joist in different directions. I'll show you that in a moment. An example for MEP engineers would be to, when you're laying out different MEP components along the wall, you could also use those instance parameters for global parameters to set those as well. For those of you who like conceptual design, this probably is one of the most successful ways to use global parameters because you're able to relate different parts of the building to each other using either occupancy or floor area or height or length and width of massing in Revit. So the Revit Building Maker, which uses masses as its tool, you'll be able to use that as well. On the right side of the screen, I've linked those mass parameters to the global parameters, which means that you can have two masses. Each one of them have their own sets of parameters, and they're linked together to the global parameters, and they share the same global parameters. Of course, when it comes to formulas, most of us already have been to the valid formula syntax in Revit. You can access that through the help menu. I'm not expecting you to read this, but you can just go to the help menu of Revit and search for valid formula syntax and abbreviations if you needed to know how to configure your formulas for global parameters. All right, so let's take a look at the Revit example. So so the way to start a global parameter in Revit is to go to the Manage menu, obviously, and then go to the Global Parameters command, and that will open up the dialog box for global parameters. Here we have the different labels: A1, A2, C1, C2, D1, D2, etc. And you can see that these labels have been used to label the dimensions themselves. So it's just like any other parameter you have used in the past. But there's a couple of things here. It has to do with hovering or mousing over the parameter itself. It will show you what the parameter is indicating. Some of the parameters here are reporting parameters, and these are grayed out. And you can see that there are, for example, the length of the room is a reporting parameter, while the width of the room is a formula which is A1 plus A2. So for example, if you were to come here and change the length, which is A1, from 12 feet as it is right now to 14 feet, and hit the apply button, of course the room area legend will update automatically, and the rest will depending on the formulas, everything will update. Another example would be to let's take a look at room 105 is driven by occupancy, for example. So this occupancy 105 is a parameter I've added here. Of course, adding a parameter is easy as simply going to the add button and simply giving it a name and selecting which type it is. So it's just like any other parameter. Choosing reporting box will make this a reporting parameter, just like same as the length. And the tooltip over here allows you to give it a description so you can find it very quickly. Alright, so for example, in the case where we have occupancy, room 105, which is right here, right now has occupancy of 12. If I were to change that to occupancy of 15, for example, hit the apply button, the room area is going to change. The parameter R2 is going to change because it's a function of the room area, of the occupancy. Let's change it back so you can see the difference. And the room area legend will update. So this is just an example of how you can use global parameters for rooms and areas. Let me close this project and open another project. Alright, so let's open a this example here. This is the example that I call the global parameter swarm. Basically, this example is where we have a furniture layout inside a space, and some of the furniture is tied to a grid, and some of the furniture is not tied to a grid. The white furniture, the white tables and chairs, are not tied to the grid, while the colored ones are tied. So let's take a look at the manage menu, global parameters, and here we have a situation where we have parameters C1 and C2, and they are both set to 10 feet right now at the moment. And we have parameters A1 and A2, which are the length and width of the room. So these are the length and width of the room are a function of the spacing of the furniture. So for example, if we came here and said, okay, we wanted spacing C2 to be 12 feet, and let me move this over to here and hit the apply button. Okay, 12 feet, apply button. You'll see that the spacing of the color tables now is changing, and it's not even, and the spacing between these tables on the right side is not happening because it's not tied to the grid. Let me take this one step further and change it to 15 feet. Hit apply. You can see here that the grid, the tables are being laid out in certain rule, while these are not. So again, this is just another way for us to use global parameters in Revit. I'll close this and reopen another model. At this time, it will be the level offset. This one is very interesting. It took some time to put together. Here we have a sample structural model that has the floor slabs, structural columns, structural girders, and foundations, and slabs. Everything is already set here. Let me show you what I have. Back to the global parameters under the manage menu. I'm going to we have here 3 parameters that are established. One of them is called slab thickness. The other one is called top of girder and top of joist. The slab thickness is set to be 5 inches. The top of girder minus 7.5 inches, and the top of joist is 5 inches. So the top of girder takes into consideration the thickness of the joist seat. Okay, so what if we were to take all the beams in the building, all the white flange beams in the building, and change their look at their the properties on the right hand side. You can see that the z offset value is set to be parametric. I'm going to change that right here and associate that with none instead of the current value. And then I'll go and enter a random number such as -1 foot. What that will do is going to drop down these beams down by 1 foot from the level. Okay, so how do you associate those beams with these parameters, and how do you change the slab thickness as well? So what I'm going to do is I'm going to come here to the structural model. I'm going to turn this around, and I'm going to go ahead and select. There's two sets of beams. Beams that where the slab is touching the beams, and the other ones is where the joists are touching the beams. Let's start with the ones I'm going to select everything in the model, and then go ahead and deselect the beams that are in this direction. And I'll take a look at the filter here. In the filter we have different beams. I'll just pick the girders, and these would be only the girders that you see here in blue on the screen. And I'll come here and associate the z offset value with this parameter, which is top of girder, which is the global parameter. And we can see the blue beam, it went up, and it is now -7.5 inches from the level. I'll do the same thing with the other beams. I'm going to select all the beams, all the instances in the project. I need to go over here and then deselect some of the beams here, such as these. I'll simply hold the shift key down and deselect, and then make sure that I have only girders in this case, and then I'll simply come here to the properties and change the z offset value of those to top of joist. Okay, so this particular use of global parameters have to do with thickness of the slab. So let's go to the Manage menu, select global parameters, and change the thickness of the slab over here. Now these are dependent on thickness of the slab, so we can change that over here, let's say to 6 inches. And as a result, you'll see that the slab thickness will change, and the top of joist and top of girder will also change. That's how you leverage the global parameters in the model. You still have to change the slab thickness in the properties as well. All right, let me close this one down and then switch over to another. My last model here would be about the massing study. So let's take a look at that. So those of you who like to work with conceptual design, you're going to find this very interesting. It's basically just a few masses put together. And we have here a mass floor schedule with the total area, surface area, and occupancy of these spaces. I'll start by turning on the Show Mass tool. That will make this blue. And let me show you first what I have before we start modifying these. Obviously, when we modify the purpose of this is to modify the parameters of one of the masses, which affect the other masses, which affect the global parameters and affects the mass floor schedule, all tied together. Let's take a look at the global parameters that we have here for the masses. We have height, top dimensions, bottom dimensions, and heights controlled by these global parameters. We also have the occupancy in the area. So let's dig a little bit deeper to show you what that means. I'm going to select one of the masses. This is on this big tower. And I'm going to edit this mass in place. When I do that, you'll see that, let me change the scale of this. Right now it's set to 160. We'll go a little bit lower. Okay, so this tower mass has a height parameter, has a top width, top length, and base width and base length. These parameters are, let me cancel this and go back. One more time, these parameters have been tied in the properties over here to another parameter called global parameter. So you can see that they're controlled by a higher level of control. Same thing goes with this and with the other tower. If I were to select the lower tower, we see that the same thing is happening in the properties of this tower. So if we were to go back to the global parameters and start establishing some relationships between these different towers based on some design intent. For example, if I came in and started, let me move this away from this, and change the height of this tower from 220 feet, say, to 245 feet, you can see that both towers are reacting to each other, and the areas are updating. I'm going to change the top dimension from 120 to 130. Okay, and then I may change the base as well. Okay, so we've changed the masses in different places, and what's left is for us to update using the Revit Building Maker. We will select the entire building, go to the filter, select all the components that can be modified through Revit Building Maker, such as floors, roofs, walls, and curtain systems, and simply see the difference here between the two. Update to face, and all the enclosures will update. We have lost a couple of surfaces here, but this is easy. You can just always put them back in. We have a couple of curtain systems that needs to be put back in, and that task is pretty easy. Just simply go to the massing menu, use curtain system, point to it, create system, point to it, create system. Of course, in the meantime, our schedule is being up to date and works also with areas and occupancy. So it's a pretty powerful tool to use with global parameters when you're trying to define certain design intent. Okay, so we'll do a time check. We have about 25 minutes left. Let me switch back to the PowerPoint and continue. So we'll take another 5 minutes and then turn it over to Casey. So what does this mean to you as an AEC professional? For architects, it means designing better buildings You have more design options. You can communicate design intent and code requirements, create rule-based design, leverage the power of global parameters in fine-tuning design. And for engineers, reducing redundant rework, rationalize building systems, use an intuitive design process, manage risk, control quality. And for construction professionals, is to build in a smart process, understand systems integration, fast-track project schedule, using alternative means and methods for construction, and system rationalization and leverage BIM for quantification. There's a couple of resources and keywords I'd like to leave you with before we wrap up. There is a specific video here by TED Talks I'd like to show you that relates global parameters to quadcopters. And this is not related to AEC, but as you can imagine, it is it has to do with arrangements of model-based design and arrangements of spaces. So let me show you that video. It takes less than a minute and a half.
Quads are extremely agile, but this agility comes at a cost. They are inherently unstable, and they need some form of automatic feedback control in order to be able to fly. So, how did it just do that? Cameras on the ceiling and a laptop serve as an indoor global positioning system. It's used to locate objects in the space that have these reflective markers on them. This data is then sent to another laptop that is running estimation and control algorithms, which in turn sends commands to the quad, which is also running estimation and control algorithms. So how does one design the algorithms that create a machine athlete? We use something broadly called model-based design. Machines can not only perform dynamic maneuvers on their own, they can do it collectively. These three quads are cooperatively carrying a Skynet. They can form an extremely dynamic and collective maneuver to launch the ball back to me. Notice that at full extension, these quads are vertical. In fact, when fully extended, this is roughly 5 times greater than what a bungee jumper feels at the end of their launch. The algorithms to do this are very similar to what the single quad used to hit the ball back to me. Mathematical models are used to continuously replan a cooperative strategy 50 times per second.
Okay, so hopefully this was a not only entertaining but also useful for you to kind of wrap your arms around this global parameters thing. So basically you're looking at arranging things in space that can be different locations that have some kind of relationship between each other. So I'm going to leave you with a couple of with few keywords here for global parameters through my research. Those relate mainly to multiple elements with similar remote proximity, formation, basically creating a pattern, creating crystallization, fabrication, synthesis, and coming together based on some rules, architecture, and synergy. All of these terms relate to what we're trying to do here. Other keywords relate to closure, symmetry and order, connectedness, common regions, proximity, continuation, common fate, and parallelism. So this is all about designing and working with model-based design through size, shape, color, value, texture, position, and orientation. And that's the starting point that you should start with when you define your global parameters. You need to define what the problem is, what are the constraints, what are the limits, and based on that you can find a solution to the issue you're trying to resolve. Whether it's architectural, structural, MEP, whether it's a design issue, whether it has to do with a design intent or code requirements, all of that falls into these parameters. So with that, I'd like to turn it over to Casey. Let me check here the time. I think we're good on time. Casey, back to you.
Okay, Robbie, we have several questions, so I will just get started on those. The first is, can we reference parameters from a linked model, an example, in the architectural model dimension to a structural model?
The answer is no. Unfortunately, at this time, that is not available. But in the future, maybe this would be a good feature to add to the wish list.
Okay. The next is, how do global parameters work in groups?
Groups. I've tried working global parameters in groups over the past few days, and I was not very successful because of the fact that instance parameters for groups is not available outside the group. It's possible that some of you may find a way, and if you do, please let me know. I'd love to know about it.
Okay, the next is, I am not clear on why the slab thickness did not change when the global parameter was changed.
Yeah, it's because I tied the dimension to the top of the girder and top of the joist. I was a little bit ambitious when I modeled this building. I tried to do many things at the same time, and the slab thickness itself can only be modified in the slab thickness properties, not at the dimension. So the thickness of the slab in the slab properties, the material properties, is not tied directly to the dimension. But I was more concerned about making sure that the top of the girders is at a certain level, minus 7.5 inches below the level, and then the top of the joists were at the minus 5 inches from the level.
Okay. The next was, can the thickness of the slab type be linked with the global parameter as well? That way only one value needs to change.
I'm sure if you give it some thought, that could be possible. Maybe again, in this instance, I was a little bit ambitious, and there was not a direct way to tie the thickness of the slab in the properties, in the material properties, or the type properties of the slab to the global parameter called thickness of the slab. So there may be a better way to do it.
Okay. If you assign the associated work plane of the joists and grinders to the bottom of the slab, the framing will move up and down when the slab thickness changes in one-step process. Using global parameters requires 2 steps. I think that sounds more like a comment, don't you think, Robbie?
Yeah, it could be that this is one of the things we can explore further. Yes.
Okay. Can members be modified using global parameters even if they are pinned?
Probably not. No, I would say no.
Okay. Can global parameters be used to combine totals from 2 different schedules into a combined value?
Within the same file, yes. The beauty of global parameters is that you're able to assign certain values and reporting values, and these values will be available to other global parameters within the same project. As long as you're working with the same project, you'll be fine.
How do global parameters work, if at all, with a model that is linked into another? Can they be leveraged by the main model?
No, at this time, global parameters do not work with the linked files.
Can you use global parameters in conjunction with Dynamo?
Wow, that's a good one. I'm pretty sure you could. If you ask this question, you probably know the answer already. I'm pretty sure you could. I have not tried it myself, but maybe again, if you tried it and you can make it work for yourself, let me know. I'd love to know about it.
Okay, let's say we have a big model and might have hundreds of global parameters. How do we organize them? Are there any filter criteria, or would this just be one large list as it appears in this demonstration?
At this time, there is no filtering or sorting of global parameters. They appear to be just one large list, and I agree. I think Autodesk should take a look at the way to organize them so that they don't become overwhelming. Having said that, the tooltips are very important to label those parameters. So when you mouse over with your cursor over the parameter, it tells you what the parameter is attached to, and that's going to be a big help in figuring out what parameter belongs to which component.
Okay. Can global parameters be used in a tag, for example, occupancy loads for life safety plans?
As long I don't know the answer to that, but as long as that component have an instance parameter and a way to make it parametric, then you can. If it doesn't, then you cannot.
Okay. Are GP effect model performance over constraining things? I'm sorry, constraining. That was an error.
Okay, please repeat the question one more time so I can understand it.
Are GP effect model performance over constraining things?
Okay, so if I understand this question correctly, global parameters can override constraints in the model.
Global parameters. I'm sorry, she meant global parameters. So
yeah.
Are global parameters affect model performance over constraining things?
Yeah, well, each one of those is used for different purposes. Again, go back to the definition of global parameters that I provided in the beginning of the webinar. They have different uses. Constraints are meant to tie certain components in the building with levels, grids, and reference planes. And while global parameters tend to be a higher level control that tie different things that are seemingly unrelated to each other. So it's a very subtle way. You kind of have to sit back and look at write down what do you want to use it for in terms of reporting simple values, deriving values, and then once you figure out what you want to use it for, then it'll be clear to you whether you should use a constraint, a dimensional constraint, or a global parameter solution.